Actually can be a good thing because if you're trying to fit these in a really small space, you don't necessarily want the pins connected, and then you can solder your wires directly onto here. But most of the time I do want my pins connected so I can switch them out. So I figured out a technique that works fairly well for me that I thought I'd just share with you just in case you're like me when I was just getting started and unsure of how to do it. So first what you want to do is, if you have one, just slide the Pro Mini pins into a breadboard and then set your Pro Mini on top of the pins so they just sit on there nice and straight. If you don't have a breadboard, you may be able to use a PCB board like this and just set it in there as well. That's what I actually usually do because my breadboard is usually full of wires. Okay, next what I'll do is I'll just set my soldering iron right on this gold colored pin here just to let it heat up for just a minute, and then I'll just place my solder on there after it's heated up and then just continue on down onto each pin. Make sure you get enough solder on there so the pin is connected to the board. I've actually not put enough on there occasionally, and then my connections obviously don't work. You just want to make sure you get enough on there to connect the pin to your Pro Mini. If you don't have enough on any one pin, you can just go back and just add a little bit more. So make sure you inspect it and have a nice even drop on there. And just spin it around and do the other side the same way. So my Pro Mini came with straight and curved pins for this set of connections up here. So just choose which best applies to you. I'm going to choose the curved ones here. And mine actually shipped with the little plastic piece incorrectly attached. So I need to flip these pins around. So I'm just going to pull them out of the plastic and then put the plastic piece on the shorter angled pins here. Okay, so now that I've switched out my pins, what I've found the easiest way to do this is just to flip it upside down like that, place it in there loosely, and then just solder one of the pins in, and then you can get the angle down after you have one of them soldered in. So then I just kind of bend it with my finger, being careful not to touch the pin that I'm soldering. Get the angle how I want it, and then I can continue to do the rest of the pins. And that's it. Pro Mini has been soldered.
Formulas that are made up of metals like tin or copper or lead. Personally, what I like using is 60-40 rosin core solder. That means that it's 60% tin and 40% lead. You can get it without lead, but I find that a little bit more difficult to work with. So if you're using one that has lead in it, just make sure that you wash your hands after you're done. It also comes in different diameters. You can get really thick or really thin solder. Personally, I prefer thinner because it makes it easier to fit inside pinholes, and it also makes it easier to control how much you're applying. Rosin core means that the center of the solder is made up of rosin flux. Flux is another important component of soldering. It's used for cleaning metal surfaces and removing oxidation and just getting them ready to accept solder and fuse with it. There are a few different types of this as well. Some of them are very thin and basically evaporate as you work with them, and some are thicker, although those thicker ones can leave a sticky residue that is sometimes corrosive, so you'll want to clean that off with some alcohol when you're done. If you're using rosin core solder, then in most situations, you won't have to worry about using additional flux, although you'll still want to clean off that residue that the rosin leaves behind. Flux can be especially useful for working with ribbon cables or tiny pads on a PCB because it'll facilitate better surface tension to sort of pull it onto the metal pads where you want it to go. Now, a couple of common mistakes that I see people making when they're first starting out. The first is that I'm trying to figure out what these people are thinking. I think that the issue is a lot of people seem to think that the goal with soldering is to sort of melt the solder onto whatever you're trying to join together. Almost like you're squeezing icing onto a cake or something like that. That's not the case. Instead, what you're trying to do is heat up both of the things that you're trying to fuse together and then melt the solder into that. Might seem like a small distinction, but it is incredibly important. Because if you do it the other way, if you just kind of dribble the solder onto whatever you're working on, first of all, it's going to be really messy. But you'll also run into what's called a cold solder joint. That's where it might look like the two things are connected, but it hasn't actually fused with one or both of those surfaces. So you'll have an intermittent connection at best, or at worst, no connection at all. The other issue that I see constantly, the old saying, less is more, that definitely applies to soldering. You only really want to use just enough solder to make the connection. Sometimes you'll have a good reason to use a little bit more. For instance, on the Minty Pi, where the L and R button board connects to the power board, you should make those solder joints a little bit bigger because they're actually kind of physically reinforcing that connection between the two boards. But the vast majority of the time, you only want to use just enough to make that connection. If you use too much solder, then you run the risk of bridging whatever you're connecting with some neighboring components. That can be really bad, to say the least. So I'll start with probably the easiest type of component to work with, which is through-hole components. You can find all kinds of different components in this form, like capacitors and resistors and LEDs, and they've got these long legs that are meant to go all the way through a circuit board. You find these a lot in commercially made boards, like these giant capacitors on this printer controller board. For some of them, you might have to bend the legs to make them fit into the board, and I'm just using it with some prototyping board here just to give an example. Slide it into the pinholes and then bend the legs outward to hold it into place. Use the tip of your soldering iron to heat up both the pinhole and the leg at the same time, and then feed a little bit of solder onto it. A good temperature to start at was, and that's it. Like I say, really easy to work with, and you can see that I hardly had to use any solder at all. That's kind of a theme that you'll be seeing here, is only use as much solder as you actually need. Another type of through-hole soldering that I've shown a few times on this channel is attaching header pins to some type of board like this tiny Arduino board from Adafruit. These make it so that you can stick it into a breadboard, which makes it really easy to work with for prototyping. So the easiest way to attach these is to put the header pins into the breadboard so that you have everything lined up, and it'll also keep the legs perpendicular with the board. And then just like in the other example, use the tip of your soldering iron to heat up both the pinhole and the pin and feed a little bit of solder onto it. For this one, I'm using a little bit more than I did on the previous example, and that's because these are going to be under a little bit of stress as you insert it and remove it from the breadboard, so you want to make sure that it's got a nice solid connection. I like to do one on both sides, and then just go down the line and do the rest. And this is about what it should look like when you're done. You'll notice that the solder extends just a little bit up above the board and makes kind of a cone shape. And I should probably go back and clean up all the excess rosin from the solder on this one. So next up, let's talk about wire. This is the kind of wire that I like to use. It's coated in silicone, so it's nice and flexible, and it's not going to melt from your soldering iron either. It's also really easy to strip. You can do it with your fingernail, and this is stranded core wire, meaning that it's made up of a bunch of tiny individual strands of metal. You can also get solid core wire, which, as the name implies, is made up of one giant thick piece of copper in the middle of the wire. I've only needed to use this a couple of times. It's much more difficult to work with. 99% of the time you're going to be using stranded core wire. So the first thing that I want to show you is tinning wires, which is the process of adding a little bit of solder to it to make it much easier to connect to other components. To do this, strip a couple of millimeters of the wire and then twist all of those strands together nice and tight. Then you're going to heat them up and apply just a little bit of solder just to coat them and hold them all together. And that's it. This is something that you'll find yourself doing quite a bit, so it's a good thing to practice. Next, I'm going to show you how to splice two pieces of wire together, which is, again, something that you'll probably find yourself doing at some point in the future. There are a few different techniques for doing this, but here's how I like to do it. Strip off about 5 millimeters of both sides of the wire, twist the strands of wire together, but don't add any solder to it just yet. Then after we're done, we're going to need something to cover up the exposed wire. I like to use heat shrink tubing, so take a small piece of that and slide it over one of the wires. Obviously, you want to do this before you connect them together. Now take both halves of the wire and twist them together nice and tight. Battery to this charging board. To do that, first prep the pinhole by heating it up from one side with a soldering iron tip and feed a little bit of solder down into there. Then you're going to want to twist and tin the wire like I just showed you, then heat up the pinhole and slide the wire in from the other side. Now in this example here, I actually didn't feed quite enough solder down into there, so I went back and added a little bit to the back. This is about what it should look like when it's done. As you can see, the hole is completely filled, but it doesn't stick out very much at all. It's nice and smooth. Also, notice that I don't really have any wire exposed on the top of the board here. I inserted the wires all the way into the pinholes so that there's no metal exposed and you can't accidentally short something out. Sometimes you need to attach wire to a board that doesn't have pinholes, so you'll be attaching them directly to pads on the board, like with this retro PSU board from Helder. Really nice battery charging and boost board. So anyway, I'm going to be attaching a couple of wires to these battery pads here to add a JST connector to make it really easy to connect and disconnect a battery. So first, again, strip a couple of millimeters of the wire, twist it, and tin it, just like you've seen me do now in a couple of examples. Should look about like this when you're done. Some types of wire like this you need to be a little bit more careful with because they do melt, unlike that silicone coated wire that I was using before. Then heat up the pads that you need to attach the wires to and feed some solder onto the board right at the tip of the soldering iron. This is about what it should look like when you're done, just a couple of nice smooth bumps that stick up maybe a millimeter or so. Then you can heat up those blobs of solder and just kind of insert the wire into them. Having them tinned beforehand makes it so that they should just kind of get absorbed into that blob of solder pretty easily. Notice that I only stripped as much wire as I needed. Beyond just keeping it nice and clean looking, that's really important so that you make sure that you don't accidentally short something out somewhere. Another type of soldering that actually I'm not sure if there's an actual term for it, but it's really popular with the types of projects that you see on this channel. For example, with Kite's Circuit Gem for the Sega Dreamcast VMU shell. Anyway, you'll see pads on a board that correspond with pinholes on a separate component, in this case a Raspberry Pi Zero. And the goal is to melt solder down into the pinholes and onto the pads behind them, thereby fusing the two boards together. I've shown this technique with several different projects on this channel, such as Ampersand's Null 2 project, which made heavy use of it. I'm actually a pretty big fan of that design because it lets you use cheap, off-the-shelf components on top of a relatively simple, inexpensive PCB. We also use this technique in the Minty Pi to make it quite a bit thinner because we don't need any header pins. The two boards are just fused directly together. Now this type of soldering is definitely a little more challenging, but I really think that if you practice at it, you can get the hang of it. Now a common mistake that I see with this type of soldering is that people try to just kind of drizzle solder down into those pinholes. That is not going to work at all and you're just going to make a big mess. Instead, like I mentioned earlier, the goal is to heat up both the pinhole and the pad underneath it, so you want to use a finer soldering iron tip that can actually reach down into the hole a little bit for this type of soldering. Don't go too thin though, because then there's not enough surface area or mass to be able to transfer the heat onto the pinhole and the pad underneath it. So anyway, like I've shown in several previous projects, what you want to do is put some solder down into the pinhole and then insert the soldering iron tip behind it. Stick it down in there for a few seconds to make sure everything gets heated up, and then remove it quickly. And if you did it right, then there's a good chance that you'll see all the solder kind of settle down into the hole there. For this type of soldering, you're definitely going to want to have a multimeter so that you can check continuity between what you just soldered and wherever that pad leads to. Some projects like the Null 2 and the Minty Pi will have test pads on them so that you can test continuity between each pin that you just soldered and that test pad. If you find that you have not made a good connection, then my kind of go-to trick for fixing those is to take a piece of wire, heat it up, and stick it down into the pinhole in question, and you can kind of wiggle it around and hopefully get that solder to make its way down there onto the pad below it. Now you might be tempted to add quite a bit of solder to make sure that it has a good solid connection, but if you add too much then you run the risk of leaking solder onto neighboring pads underneath it. So you need to be careful to add just the right amount of solder. This can take some practice, and there are actually some practice boards that I mentioned in a couple previous videos that Helder designed and put up on Oshpark that you can go and purchase directly from them. They're not very expensive and they've got test pads on them, so it is worth getting a couple of sets of these and practicing on them if you're doing a project that uses this kind of soldering. As I've mentioned in previous videos, you can spend anywhere from a few dollars all the way up to several $100s on a soldering setup, and I don't necessarily recommend going to either of those extremes. At the low end of the spectrum, you're going to get an iron that you plug in and it heats up, and that's about the only control that you have over it. As you work your way up that spectrum, you'll start to see nice features like interchangeable tips, adjustable temperature, and even hot air rework guns, which can come in really handy. This is the one that I've been using for a while now. It's called the 853D. It's got those features that I just mentioned. It's also got a really handy feature, which is a built-in DC power supply that you can adjust up to 15 volts. Super handy for working on small electronics projects like you see me doing on this channel. It also has a USB power supply built in and a voltage meter as well. It's also got a really nice feature where it'll go to sleep if you don't pick up the soldering iron for a while. It'll lower the temperature until you pick it up again. You can get it for about $100 on Amazon, and to me, it's worth it. But if you're looking for something a little bit cheaper, the one that I used before this one is called the 898D. It also has adjustable temperature, interchangeable tips, as well as a hot air rework gun. You can get this one for about $60. Now, a few additional tools that I'd recommend for getting started. First, you're definitely going to want to get a multimeter. It's of course useful for checking voltages or measuring resistance, but the thing that I use most often is a beeping continuity check to make it really easy to check and make sure that you've gotten a good connection. Next, a set of helping hands. I'm a big fan of quad hands, but there are other cheaper ones on Amazon that I'm sure probably work just as well. I'd also recommend a couple of things for taking care of the tip of your soldering iron. First, a wire type tip cleaner like this one. As you're working on a project, you'll accumulate some buildup on the tip. One of these makes it so you can clean it off periodically while you're working on something. The other thing that I recommend is a tip tinner and cleaner like this one right here. Basically, when you're done working on a project, you can stick the tip in there while it's still hot, and then clean it off, and your tip will look brand new when you put it away. These tips do wear out over time, but taking care of it like this will make it last a lot longer. And then the other thing that I'd recommend is a silicone pad to do all your soldering on. Basically, nothing sticks to them, including solder. It's not going to melt it if it drips on it, and you can get them with these built-in trays to hold screws and things like that while you're working on projects.